Salutations, mini mathematicians. Thank you so much for joining me today. We're working on 5.2c, volume of spheres, and it's not on Desmos, it's on a PDF. And so our purpose is we are going to derive the formula for the volume of a sphere from what we know the volume of a cylinder, and we're going to compare parts and volumes of prisms, cylinders, cones, and spheres today. So what we're going to do is we're going to start by making a prediction. So if you have a cylinder and a sphere with the same radius, and the height of the cylinder is twice the length of the radius, predict what fraction of the cylinder's volume would equal the volume of the sphere. So I know that's a lot, so let's break it down. So what we have, if we are going to have a cylinder and we're going to have a sphere, and they have the same radius and the height, so they have the same radius. So let's think about this. We have the cylinder and we have a sphere. Maybe yours look better than mine. And we know they have the same radius, so this is equal to r for the radius. But notice what's interesting about a sphere is that if I have the radius, which is also the amount from the center to the end of the sphere anywhere, right? It's all a radius. The height then, if we had a height of the sphere, is 2r. And it just says the height of the cylinder is twice the length of the radius. So that's where that came from. So it says predict what fraction of the cylinder's volume would equal the volume of the sphere. So which one would be bigger? Which one can we fit inside the other? Well, in fact, we can place that sphere inside the cylinder. So here's the sphere. And here is the sphere fitting inside that cylinder with a height of 2r and a radius of r. So we believe that the volume of the cylinder is equal to some number times the volume of the sphere. So what do you think? Do you think the sphere takes up half the cylinder? Do you think the sphere takes up a fourth? Is it 4/5 of it? Is it 3/5? Is it 3/4 of it? Is it 9/10 of it? What do you think? What do you think? How much of the sphere fills in the cylinder? And maybe you already watched the rest of that video we looked at last time, but if not, we're going to finish watching that at this time to compare that sphere with the cone and the cylinder. And these all, remember, have the same height and the same radii. So of course, we're going to fill up our sphere with our water. It's really difficult to fill this one up as carefully as we can. And we're going to fill that into the cylinder. Notice our cylinder is still spaced off with 1/3 markers. Oh my gosh, it's more than a third from our cone. We measured our cone. And it is, I gotta shake out all that water, exactly 2/3 of the cylinder. Ah, amazing. So that's going to help us derive our equation. Okay, so taking a look. Sorry, you guys, technical difficulties. Okay, so taking a look, what we're going to do is now that we know that the volume of the cylinder is equal to 2/3. Oh, I guess we would say that the volume of the sphere is equal to 2/3 the volume of the cylinder. Amazing. So now what we're going to do is use the volume of the cylinder to complete the calculations here. So here it says, write down the equation for the volume of the cylinder where the height is twice the length of the radius, or 2r. So if we have a cylinder and we have the radius and then the height is twice the radius. Well, we know that volume of a cylinder is pi r squared h, But now our H value is 2R. So because all these values are being multiplied together, we can use the commutative property of multiplication and move around the factors. So I'm going to write this as 2 times pi times r squared times r to the first. And because we know so much about exponent properties now, we know when we're multiplying with the same base, r squared times r to the first, we add our exponents and we're going to get 2 pi r cubed. So that would be the equation for the volume of a cylinder where the height is twice the length of the radius, or 2r. So now what we're going to look at is we're going to look at a sphere. If a sphere has the same radius of the cylinder, manipulate the equation to show the volume of a sphere. Well, we know that the volume of a sphere, gotta make it look three-dimensional as much as I can, volume of a sphere is equal to 2/3 the volume of the cylinder if the height is twice the radius and they have equal radii. So let's take a look at that. Well, this is going to be 2/3 pi r squared h, where we know pi r squared h simplifies to be 2 pi r cubed. So up here we're going to have 2/3 times 2 pi r cubed. Okay, so let's simplify this. Multiply across with the fractions. 2 times 2 is 4. So we're going to have 4 pi r cubed all over 3, which we can write it as 4/3 pi r cubed. So I want to remind you on your scientific calculator, when we are looking at cubing something, we're going to use that caret button, that shift 6. And some calculators will have an x to the y power button instead of a caret button, where you put a base in, then you press x to the y, and then you press your exponent and then equals. You can also look up a how to do this on your calculator video on YouTube if your calculator is different. So if I wanted to cube something, always pick a number you know to practice on your calculator. So I know 2 cubed, 2 times 2 times 2 is 8. So if I put 2 and I press caret and then I press 3, 2 to the third power is 8. So I feel really good about this. Sometimes you can always use parentheses around your base number if you want to, but they are not needed. Okay, so it says state the equation for the volume of a sphere. Well, we know that the volume of a sphere is equal to 4/3 pi r cubed. And how does this equation relate to the volume of a cylinder? Well, we know the volume of a sphere is 2/3 of a cylinder with equal radiuses, equal radius, making the height equal twice the radius. Because we notice with a sphere, the diameter is equal to the height. Okay. So now that we've explored the volume of a sphere and we know the volume of a cylinder and the volume of a cone, let's look at all of them together, base compared to our base shape, the cylinder. So if we have a cone, a sphere, and a cylinder, all with the same radius, and the height of the cylinder is twice the length of its radius, and of course also the cone, right then. How does the volume of the cone and sphere relate to the volume of the cylinder? So we're not comparing the cylinder to the cone and the cylinder to the sphere. We're relating the cone to the cylinder and the cone to the sphere. Sorry, the sphere to the cylinder. So I'm very visual, so I like to draw a picture. So here is our cone. We know that the radius is r and the height is 2r, and we know the volume of a cone is 1/3 pi r squared h. Be careful as we're dealing with these shapes if versus squaring versus cubing. Very different and very important not to mess that up. So here we'd have 1/3 pi r squared times your h to r, and we can move around these terms so that we would get 1/3 times 2 is 2/3 pi, and then r squared times r is r cubed. Moving on to our sphere, if we have our sphere here with radius r, we know the volume is 4/3 pi r cubed. And if we look at our cylinder with radius r and height 2r, since we know the volume is pi r squared h, and we can always just look above with what we did, but if you want to see it again, pi r squared times the height, which is 2r, bring the 2 in front, 2 pi r squared times r is r cubed. So taking a look here, how do they compare? Well, the cone and the cylinder, if we look at these volumes, notice this is 2/3 pi r cubed and this is 2 pi r cubed. So I'd have to divide the volume of the cylinder by 3 to get the volume of the cone, which means the cone is 1/3 of the cylinder, which we knew that from when we derived the formula before. So the cone is 1/3 of the cylinder, which is really important. Cone is 1/3 of the cylinder. And the sphere is, well, if we look at the sphere, this is 4/3 and this is 2. So to go from 2 to 4/3, you would multiply 2 by 2/3. So the sphere is 2/3 of the cylinder. Probably should have said the volume of them, but I didn't have a lot of room. So the sphere is 2/3 of the cylinder. So that's important to remember for when we derive these formulas, so it helps you not need to memorize them as much. Okay, so let's look at the directions and apply our formulas. It says find the volume of each figure described below. Use 3.14 for an approximation for pi and round to the nearest tenth when needed. Show all your work. So I'm going to do 4 with you. Taking a look at 4, my radius is 5, and it's important to avoid that diameter monster. So I always like starting with writing my formula. So this is a sphere. So it's 4/3 pi r cubed. So 4/3 pi, your radius is 5 here being cubed. So we have 5 cubed. And if you're not sure what that is, you can always grab your calculator. 5 to the third power is 125. So you have 4 times 125 pi divided by 3. So since you have the 125 times 4 is 500. And we know dividing things by 3 usually ends up in a repeating decimal. So a lot of times I will leave this as like 500 pi over 3 and then round to my approximate answer. So then 500, you can divide it by 3 and then multiply by 3.14. Remember, you don't want to round until the end, so it's really nice to just keep working with the number that was previously in your calculator. Or if you had 500, you could always multiply that by 3.14, press equals, and then divide by 3. Be really careful with your calculator because it does not do in order of operations. If I said 500 times 3.14 and then divide by 3, it's actually going to do this division first and then multiply, and you're not going to always be getting the right answer sometimes. So in this case, it was okay, but we just really want to be careful with it. So when we do this, this is approximately 523.3 meters cubed or cubic meters. And it's really important to make sure you have your units in your final answer. Okay, I'd love for you to finish number 5. Make sure to show all your work and be rounding to the nearest tenth. Okay, let's see how we did on 5. Taking a look at number 5, notice they gave you a diameter. So half of 6.4 is 3.2 feet. Plugging that in and following my order of operations, I got approximately 137 and 2/10 cubic feet. Nice work. Let's move on. So what we're going to be looking at now is a hemisphere. So careful, 6 and 7 are different problems. I know they're kind of on the page, kind of swooshing together. So it says a hemisphere with a radius of 1.3 yards. So a hemisphere is just half a sphere. Well, if we know that the volume of an entire sphere is 4/3 pi r cubed, the volume of a hemisphere, so there's half of a sphere. Well, what's half of 4/3? It's 2/3, so it's 2/3 pi r cubed. So this is going to be helpful with a lot of future problems. Hint, hint, over here there's a hemisphere. Or you could always find the volume of the whole sphere and then divide it by 2 at the end. But let's just be more efficient and think, well, if 4/3 pi r cubed is a whole sphere, half of 4/3 is 2/3. So let's use that. Okay, so now we have to plug in our value. So 2/3 pi, our r, make sure you did give us a radius, 1.3 being cubed. So I'm going to definitely need my calculator. Grabbing this. Sometimes I do like to put parentheses around when I'm dealing with the decimal. Make sure you're cubing, not squaring. So 2 times 2.197 divided by 3, pi is in the numerator. So from 2.197, I'm going to multiply that by 2. I'm going to divide that by 3, and I'm going to multiply that by 3.14. And we get approximately 4 remember we're rounding to nearest tenths. There's a 9 next door in the hundredths. So this is approximately 4.6 cubic yards. Make sure you're using that approximate symbol and make sure you are boxing your final answer. Okay, so taking a look at 7, I'll help you set it up. So our total volume is going to be the volume of the cylinder, because this is a compound shape, plus the volume of the hemisphere. So down here, I'm going to find the volume of the cylinder, and I'm going to find the volume of the hemisphere so I can add them together. I really like to leave my answers in terms of pi until the end, and that's going to give us the most accurate answer because you don't want to round until the end. If you are not leaving your answers in terms of pi and you're giving an approximate, give it to like 4 or 5 decimal places if it has it, just because we don't want that rounding to affect our final answer. So why don't you finish 7 and work on 8? Work on 7 and finish 8, and we'll go over the answers as soon as you're ready. Okay, let's take a look. So number 7, like I said, I like to leave my answers in terms of pi. So my cylinder, I got 6,750 pi, and my hemisphere, I got 2,250 pi. So then when I added those together, I got 9,000 pi cubic centimeters. So when I round at the end, you're getting 28,260 cubic centimeters. Nice job. When you're looking at number 8, when we're looking at number 8, we have a sphere fitting perfectly inside a cube. So that means that the side length of the cube is equal to the diameter of the sphere. So the radius of the sphere is half of the side length of the cube. Well, we know a cube, the volume of a cube is side times side times side, or side cubed. And we looked at this last year when you guys looked at prisms, and a cube is a special type of prism. So from here, 64 is equal to s cubed, so the side length is 4. 4 times 4 times 4, 4 cubed is 64. If you weren't sure, you could always be plugging in numbers to be thinking about, like what's 2 cubed? What's 10 cubed? What you can also do is you can do a cube root. So cube rooting undoes cubing, just like square rooting undoes squaring. So to do a cube root, because notice the x squared and the square root are the same button. You just have to use your shift to get to the square root to undo. So for example, I know that the square root of 16, because 4 squared is 16, the square root of 16 is 4. So what I would do is I would press the second and the x squared to get that square root symbol, put in 16, and I would get 4. Well, cube root, similarly, I know that 3 to the third is 27. So the cube root of 27 is 3. So I'd press second caret instead. And I would put, oops, I put the answer. So second cube root, 3, because we have to say what cube root we're looking for. Then put in the cube root. So we know that we are doing 3 is the cube root, the root number that we're taking, and 27, and then press equals, and we'll get 3. If we try a different one, we know that 5 cubed from earlier is 125. So if I want to find the cubed root, I say I'm taking the third root, or the cubed root. I'm going to put in my cube root or any root button, the x root. I'm going to put in 125, and I should get 5, and I do. So something you could do, I know I want the cubed root, so I'm going to press second, and then I'm finding the cube root of 64, which is 4. Cool. So if the side length is 4, we know the radius is 2, and then we're going to just do our calculations to get our volume to be approximately 33 5/10 cubic feet. Nice. So let's apply our knowledge to some word problems. So we're going to be solving these word problems. We're going to show all our work. We're going to use 3.14 to approximate pi. We're going to round to the nearest tenth when needed. We're answering a complete sentence. I'm going to underline this like so many more times because some of you guys have been skipping this. So don't skip it. If it's in the directions, it's worth points. Okay. And if you're not reading the directions, you're probably missing important things. So we have a golf ball and a tennis ball. Okay, so a golf ball has a diameter of 4.3 centimeters, and a tennis ball has a diameter of 6.9 centimeters. Find the difference between the volume of the golf ball and the tennis ball. So difference means we're going to subtract the volumes. So to organize this, I'm going to find the volume of the golf ball first. And it's important to draw a quick picture just because we don't want to miss anything. So see, it says diameter of 4.3 centimeters. Oh no, you guys, diameter monster. Rawr, rawr, rawr. So we want half of 4.3. So you can just grab your calculator if you're not sure. But the radius or half of 4.3 is 2.15. So from there, we can go into our formula. Volume of a sphere is 4/3 pi r cubed. A golf ball is a sphere. If you didn't know, you could always Google it, I guess. What shape is a golf ball? From here, 4/3 pi times your radius being cubed, 2.15 cubed. Can grab your calculator here and do 2.15 raised to the third. And you get this beautiful decimal. So you know you're going to have 4 times this decimal, 9.938375 pi divided by 3. And pretty much just from here, you don't really need to put this big decimal on your paper. We're just using the calculator. So we just have to be really careful. Notice I don't want to clear this button, so I'm just going to multiply that by 4. I'm going to divide that by 3. I'm going to multiply that by 3.14. Always be checking to make sure you're not making a mistake, pressing the wrong button. So this is approximately, I made a mistake here. Let's see. 2.15 to the third power times 4 divide by 3 times 3.14. Much better. What's going on? Let's see. 2.15 to the third power times 4 times 3.14 divided by 3. Okay. Approximately 41.608. Oh, 6633 centimeters cubed. I was looking at my answer key, you guys, and I left it in terms of pi. So notice I was like, why am I not getting 13? So sometimes leaving answers in terms of pi, especially when you're going to be subtracting, is going to make it more accurate. So I'm going to do that here just to make sure I'm more accurate. So I'm going to take 2.15 cubed. I'm going to take this number. I'm going to times it by 4. I'm going to divide it by 3. And instead of multiply by 3.14, I'll use this. So I know that this is approximately 13.25116 pi. So I'm going to use this number just so it's a little bit less of an approximation than this next number. But I should get pretty much the same answer since I went so many decimal places. Okay, so now we need to find the volume of the tennis ball. So we know the tennis ball, it's a little bit bigger than a golf ball. Tennis ball is also a sphere, believe it or not. They also told me, about the diameter, 6.9 centimeters. So we need the radius, which is half of 6.9, which you can grab your calculator, 3.45 centimeters. And then you can start plugging in the numbers into your formula. Volume is 4/3 pi r cubed. Yes, write the formula again. Yes, yes, yes. We're writing the formula again because that's how we're going to learn it. So here, 4 times pi times our radius, 3.45, being cubed, not squared. Careful, careful. So grab your calculator, 3.45 to the 3rd power. We get this beautiful decimal. I'm going to multiply that by 4. I'm going to divide that by 3. So I'm going to change this to an approximately 54.7515 pi cubic centimeters. Okay, so now they asked us to find the difference. So when I am looking for the difference, remember, we are going to take the volume of the tennis ball and subtract the volume of the golf ball. And I know it's like, why am I writing this down, Miss Barr? Well, it's easy to mix up the numbers, right? So really helpful to give yourself a problem-solving plan. Okay, so volume of the tennis ball, we have 54.7515 pi. This is approximately minus 13.25116 pi. And notice these still have that pi there. So we can think about pi like a variable. Like if you have 54.7515 pies and you subtract 13.25116 pies, how many pies do you have left over? No pies, we ate them all. So here, 54.7515 minus 13.25116. Really careful as you type those into your calculator. Again, approximately 41.50034. Multiply that by 3.14 to get your approximate answer of 130 point. This is where you round. The end is where you round. Don't round to the end. 0.3 centimeters cubed. And do not forget your answer in a beautiful sentence. Go back to what the question is asking. Find the difference between the volume of the golf ball and the volume of the tennis ball. The difference in the volumes is about 130.3 cubic centimeters cubed. Start with the capital, end with a period. Nice job, mini mathematicians. Okay, so you're going to be doing the same thing with 2 different shapes, asking a little bit of a different question. We're looking at a cantaloupe, yum, delicious melon, and a clementine orange, yum, delicious fruit, a little cutie, maybe a halo. So you're going to calculate the volume of the cantaloupe, calculate the volume of the orange. How many times bigger is the cantaloupe than the orange? This is your final question, so we are not rounding until the end. Okay, go ahead, pause the video, and we'll go over the answers as soon as you're ready. Okay, number 10. So the cantaloupe diameter was 23 centimeters. So of course we do not use the diameter in our formula, we use the radius. So we know the radius 11.5 centimeters. Did you fall for the diameter monster? Go back and fix your work. So here, volume, we get approximately 2,027.833 pi centimeters cubed, which if you round it all the way, we get approximately 6,367.4 cubic centimeters. So I gave both answers, an approximate in terms of pi and an approximate with pi using 3.14. And then when I calculate the volume of the orange, very similar, they gave me a diameter, so I need to change the radius, and I got the volume to be about 57.166 pi cubic centimeters, which is approximately 179.5 cubic centimeters. And so then the final part, we're asked how many times bigger. If I'm asking about how many times bigger, I'm using division. So if you use the answers in terms of pi, the pi's cancel out. And if you use the other approximate answers, you're going to get the same answer too. So the cantaloupe is about 35.5 times bigger than the orange. So you can be rounding to the nearest tenth. You saw a 7 next door. And like I said, even if you used our approximate answers, let's see how we do there. So 67.4 divided by 179.5. Again, you're still going to get 35.5 times bigger. Make sure you wrote your answer in a complete sentence. Okay, so last problem, number 11, I would put a star next to it. It's a great problem. So we are pouring water out of a cylindrical vase. So we have a cylinder and it's filled with water. And we're pouring that water out into a spherical vase. We all know how tricky it can be to pour water. So we want to know, and it gives you some information about the shape. We want to know, will the water overflow? Does this volume, is it less so that when we pour it in, there's not enough room? Or is this volume greater so when I pour it in, I'll have extra space? So will the water overflow? If it does, by how much? And if it doesn't, how much extra space is left over in my spherical vase? Okay, go ahead, finish number 11. Don't forget to answer all parts of this question, and we'll go over it as soon as you're ready. Okay, number 11. So when I calculated the volume of my two vases, my cylindrical vase, we ended up with 800 pi cubic inches. And my spherical vase, we get 256 thirds pi cubic inches, which is 85 and a thirds pi cubic inches. So you could rewrite them as kind of mixed numbers to compare which one's bigger, or you could rewrite them both as thirds. So 240 thirds, 256 thirds pi cubic inches. So will the water overflow? No, the water is not going to overflow because the water starts in the cylindrical vase, which has a lesser volume than the spherical vase. 80 pi is less than 85 and a third pi. The remaining space will be, and I showed some work when I subtracted, approximately 17.6 cubic inches of space in the spherical vase. Oh, kind of rhymed there. So again, thank you so much for your hard work. Make sure you're scanning your notes in. Stay psyched, make it the best day ever, and I will see you next time.